real numbers and their decimal expansion. To understand this topic, we are taking here example number 5 of the textbook. The question is, find the decimal expansion of 10 upon 3, 7 upon 8 and 1 upon 7. By doing this example, we will understand real numbers and their decimal expansion. So here I am doing the division. The first division is to do 10 upon 3. So here I am dividing 10 by 3. So when I do it, I find it that it is 3 3s are 9. 10 minus 9, I will get the remainder 1. And as I got the remainder 1, I have nothing to take down from the dividend. I will put the point here and I will put a 0 here. As a result, it again became 10, and so again it will go like 3 3s are 9, 10 minus 9, 1. What again we got the remainder is 1. Again we will put a 0, it will become 10, and again 3 3s are 9. So this cycle is going to continue forever till infinite times. Okay, so always we will get the remainder 1, we will put the 0 and 3 3s are 9 and so on. This is going to continue. As a result, the value of 10 upon 3 we are going to get is 3.333, but how many times? Infinite times 3 is going to come. So as a result, we show it symbolically by doing this 3 points, which indicates that this 3 is going to continue forever after the decimal. Okay, so the value of 10 upon 3 is 3.333 and so on. Okay, which symbolically we can write it as 3.3, and as after decimal this single digit 3 is going to repeat infinite times, will make a bar above this 3 which is after decimal. The meaning of this bar is that this 3 is going to repeat infinite times, unlimited times is going to repeat. Okay, and this form of decimal expansion is called as non-terminating. It is called as non-terminating. Okay, non-terminating means non-stop. The answer will never stop. The quotient is going to continue forever. That is what non-terminating means. Terminate means to get stopped. Non-terminate means non-stop. Okay, and we can also see that this 3 is going to repeat again and again, so we will write it here recurring. Okay, we will write it here recurring. Recurring means to reoccur. The 3 is going to reoccur again and again. That is why recurring. So the decimal form is non-terminating recurring. Okay, and remember here that whenever the decimal form is non-terminating recurring, that means it is a rational number. So after this point, write down below that the number is rational number. Okay, so here we did the 10 upon 3 and we understood the decimal form, and we concluded that when the decimal form is non-terminating recurring, it will be considered as a rational number. Okay, now let's go for the next division. So I am erasing this and let's do 7 upon 8. So dividing 7 by 8, here 7 is a smaller number than 8, so I have to put a 0 point here and I will place a 0 after 7. As a result, this will become 70. Now I have to take a number which is smaller than 70 but closer to it, so it is 8 8s are 64, and when I do the subtraction, I will get 70 minus 64 as 6. I will put a 0 here. It will become 8 7s are 56. The remainder I will get here is 4. I will put again and one more 0. It will become 40, and it is 8 5s are 40, and 40 minus 40 will give us remainder 0. Here we got the remainder 0, and when the remainder becomes 0, we have to stop the division. In the previous case, we didn't got the remainder 0. We were getting the remainder 1, and 3 3 is 9, 1. The remainder was always 1, and that means we will never get 0. in that case of division. Okay, and it was non-terminating. Here we got the remainder 0, that means we have to stop the division here, and here we have to write that 7 upon 8 means 0.875, and 0.875, that's it, that is the answer. After 5 there is no other digit coming, it is stopped. So this form of decimal is called as terminating. So as I explained you, terminate means to get stopped. The division has been stopped, so it is terminating. Okay, so when the decimal form is terminating, that also will be categorized as a rational number. So write down below this point that this also is a rational number. Okay, so here from this two division we concluded that decimal form rational number in decimal form can be of two types. First is a non-terminating recurring, and the second is it can be only terminating as well. Okay, now let's see the third division, 1 upon 7, and see what do we get from there. So I am dividing here 1 by 7, 1 which is smaller than 7, so I will put a 0 point and a 0 here. As a result I will get 7 ones are 7, 10 minus 7 I will get 3 as a remainder. I will put a 0 here, 7 fours are 28. After subtraction I will get 2 here, putting a 0, 7 twos are 14, 6 0 60, 7 eights are 56. 60 minus 56 I will get the remainder 4, putting a 0 it will become 40, 7 fives are 35. I'm continuing here. After 40 we got 35, 40 minus 35 I'll get the remainder 5, putting a 0 here, 7 sevens are 49. 50 minus 49 I will get the remainder 1, and here where I have to stop my division. Okay, so how did I came to know that I have to stop my division here? Because I got the remainder 1, which is as equal to the dividend from where I started. I started dividing 1 by 7, and this is what I got when I did it. And now as I got the remainder 1 again, that means again I will put 0, it will become 7 1 is 7, and this cycle is going to continue again. That means in this division also we will never get 0 as the remainder. Okay, and that means after this 0.142857, again after 7 this cycle is going to continue, 142857, 142857, 142857, and so on. So as a result we will write the decimal form as for 7 by 8, sorry, not by 7 by 8, it is for 1 by 7 as 0.142857, 142857, and so on, dot dot dot, forever. Okay, so in the first case it was only one digit which was reoccurring, which was 3, but in this case it is a block of 6 digits which is going to reoccur. So this number can be anything, but always it will be less than the divisor. In this case 1 upon 7, the divisor is 7. So as a result the number of repeating digits here is 6. It will not be more than 6. That is what we will conclude here. So I will write here 0.142857, and above this I will make a bar. Okay, so this is the value. And what about the decimal form? The decimal form is nothing new, but it is the same which we saw earlier. It is non-terminating, it is not going to stop, but it is recurring. Non-terminating but recurring, and as a result this number is also a rational number. This is also a rational number. So dear students, what is the conclusion after this particular example? We understand here that Real numbers, as you all know, is a set combining both rational and irrational number, right? So real numbers, I am making a chart here in which you can see that real numbers consist of all rational numbers as well as irrational numbers. Okay, but in the decimal form, how will you find out whether the number is rational or irrational? So rational number have two types in their decimal form. The first type is, it will be terminating. Okay, as we saw the example of when we did the division of 7 upon 8, right? I guess yes, we did the division of 7 upon 8 and we got 0. Example 0.875. okay, then also I can give you an example 2.34, 4.96432, and so on. Many examples are there. The only thing is that after decimal there will be a limited number of digits coming. There is no dot dot dot, which explains the division is going to stop at some point. Okay, so 0.875, 2.34, 4.96432, anything after decimal there should be limited digits, so that is terminating, and then it will be called as what? Rational number. The second category can be, in the case of rational number, which we saw, non-terminating and recurring. Non-terminating but recurring. Also we saw the example of this as 3.3, and we made a bar about 3, which indicates that 3 is going to reoccur. Example. Then we also saw 0.142857, and we made a bar above it. That is also a rational number, non-terminating, recurring. Then you can see 3.423, 423, and so on. If I make points after that, that means this 423, 423, 423 is going to reoccur again and again and again, and that is why that is also non-terminating, recurring, and it is a rational number. Alright, now when it will be called as an irrational number in the decimal form, so there is only one case, and that is when it is non-terminating as well as non-recurring. When the number is non-terminating as well as non-recurring, in that case we will consider it as an irrational number. Like example, if we see in your textbook, you can see value of pi. It is given also in class 9th. Sorry, this is class 9th only. Yes, so the value of pi, you can see in your textbook given that 3.141592653, 592, and so on, 653. There are so many digits are given after the decimal. What we take the value of pi while doing any kind of sums in geometry is 3.14, or we take is 22 upon 7, but that value is not the exact value of pi. When you do 22 upon 7, you will see that the decimals of the value after decimals will not be reoccurring. It will be randomly, any digits will come and it will continue forever. Okay, so it's also 3.141592 and so on. Any random numbers will come, and that block of digits will not reoccur like this. It will not reoccur like this. So that will be considered as, it is non-terminating, it is going to continue forever, and also it is non-reoccurring because a block of digits are not repeating. So that type of number will be considered as what? Irrational number. Okay, let's say if I write 0.1429364 and so on. Randomly I wrote any numbers and I put dot dot dot, which indicates it is non-terminating and non-reoccurring. It is an irrational number. Also, if we consider a number like this, 0.1010010001 and so on. Okay, dear students, pay attention here. It is 1 0 1 0 0 1 0 0 0 1 and so on continue. You will see that only 2 digits are used here after decimal, that is respectively 1 and 0. But this will not be considered as non-terminating recurring, because the value of 0, the number of zeros are increasing after every 1. You can see at first it is a single 0, then it becomes 2 0, then 3 zeros and so on, and this is also considered as non-terminating, non-recurring. As a result, it is also an irrational number. So this is the video which I made today for understanding real numbers in their decimal form. So now you can easily spot out which number is rational and which number is irrational if you are given a number in decimal form. If you understood this video, please like it and subscribe to my channel and share it with your friends so that they also understand the concept in an easy way.